Okay, today I will talk about the problem humble numbers. This problem is sort of similar to subset sum, except that this time it's subset multiplication with prime numbers. And noting that the subset is only made up of prime numbers is really important because if there are numbers that are not prime, you can have overlapping multiples and then it will just take more time to build. So we will use dynamic programming in this problem. Here is my code. So first we will have this empty dynamic programming array. It has a maximum size of n because we need to compute the n's humble number. So first, although it said that 1 is not a humble number, we have to set dp0 to 1 because we know that we're dealing with multiplication, not addition. So if you don't have anything at the beginning, you will always end up with 0. And it doesn't really matter about this anyways because the 0 here is not possible and will always be greater than 1. So first, I will loop through all the way from 1 to n. This way we can construct it from bottom up. And first, I will set this dpi to int max. This means we haven't found a solution for this dp yet. And then we will loop through each of the prime numbers that we have. And what this third loop inside here does is that we'll have an index for the next biggest. We will have an index to keep track of the next biggest humble number. So here we will we have to make sure that this xj, which I said here, is less than I, our current maximum number. So what this one does is that starting from the basic 1, we will always construct up. So we will always have something in the previous dp arrays, and these previous dp arrays are always composed of previous prime number multiples. So now we can test by multiplying this current prime number pj into this dp xj and compare that with the previous humble number. So if we will we'll keep on going through this loop until we've reached an index xj that is greater than the previous dp value. So then this means that we'll have found the next greatest humble number for the number n, or for the number I. And here, since we need to check each of the prime numbers, we will have to keep track of the minimum here. And since it's the minimum, but we know that this is at least greater than the dp I minus 1, the minimum will be the next greater number. And this will loop on through every I. So this is actually a really simple program as long as you know how to properly code the dynamic programming. For here, you probably shouldn't start from 0 and search all the way to the x is greater than or equal to I. You shouldn't do that because the maximum can be n, and it's going to make the loop run for a really long time. And if we do this, we know that we will always just keep on increasing xj based on our previous xj. So this won't take too much time, and this whole program will consider it to run in nk time. And so this is the best way to optimize your program to make sure it runs within the time.